So in this question, we're going to find the binomial expansion of 1 over 1 plus x up to and including the x to the 4 term. And we're also going to show this in sigma notation and also for what values our x is valid. So first of all, to start with, rewrite this where we've not got it in a rational expression. So how we're going to write this is f of x is equivalent to 1 plus x to the power minus 1. So that's another way we could write that. So now what I need to do is, from this, we can use our binomial expansion formula. So the general formula is 1 plus ax to the n. That's equivalent to 1 plus n times ax over 1 factorial. That's the first one. I can raise this to the power of 1 and then you'll see the pattern forming. And then I've got n times n minus 1 ax squared over 2 factorial. That's the second term. Third term, n minus 1 n minus 2 ax cubed. And because it's cubed, it's 3 factorial. And the final one is n minus 1 n minus 2 n minus 3 ax to the 4 and over 4 factorial. So that's our building blocks for our binomial expansion formula, and now we need to work out what our n and our ax is. Well, in this case our n is minus 1, so if I'm trying to do 1 plus x to the minus 1, n equals minus 1, and ax is just x. So wherever I see ax I put x, wherever I see n I use minus 1. So then this is equivalent to 1 plus, so minus 1 times x to the power of 1 over 1. Then I've got minus 1 minus 2. And then I've got x to the power of 2 over 2 factorial. Next one, I've got minus 1 minus 2 minus 3 x to the 3, and that's over 6. So 2 factorial I can just leave as 2. And then the last one, I've got minus 1 minus 2 minus 3 minus 4 x to the 4 factorial is 24. Okay, now let's just simplify this off. So now I've got 1 just stays as it is. Minus 1 times x over 1 is just minus x. So that just becomes a minus x. Then I've got minus 1 times minus 2 is plus 2 over 2 is 1. Times x squared is just plus. So x squared. Next term, I've got minus 1 times minus 2 is plus 2 times minus 3 is minus 6. Over 6 is just minus 1. So that's minus x cubed. And the last term, minus 1 times minus 2 is 2, times minus 3 is minus 6, times minus 4 is 24, over 24 cancels out, got x to the 4. And that's where we're up to for now. So now, what I want to do now is work out where this series would be valid, whereas this polynomial terms will all be valid. So what we do is we take our ax, in this case it's x, so ax will always be, modulus of that should be less than 1. Ax is just x, so x is less than 1. So that's where this series is valid. So I've got that there. This is our term now. And now I'm going to show you guys what it looks like in sigma notation. So here I've got 1 over 1 plus x. That's equivalent to n equals 0 to infinity. Then I've got minus 1 to the power of n, and then multiply that by x to the power of n. And that's how we could write that in terms of all of its expansions. And that's how we take care of explaining 1 over 1 plus x in binomial expansion in terms of a polynomial. Okay.